Hello, Professor. My name is Mauricio, and let's begin our midterm presentation today. My title of my project is Development of Manufacture of Electric Vehicles in Systems Engineering version, and it includes mainly three parts. The first is the background, and the second is the concept development stage, and the third is some challenges. At first, let me introduce the background. Automobiles do bring convenience to people, but they also cause serious problems at the same time. The car exhaust caused the greenhouse effect, also made the ozone layer destruct and so on. With improvement of living standards, human beings are increasingly demanding the living environment, and the call for reducing the exhaust emissions of automobiles is also increasing day by day. But the number of vehicles in the world continues to increase, making humans in various countries face many challenges. The scarcity of global oil resources reserves is indebted, and the energy shortage of several major economic powers is serious. At this stage, the development of the automobile industry, which still uses oil as its main fuel, is greatly threatened. So, under the current uncertain political and economic structure of the world, ensuring the security of oil supply has become a difficult problem that governments must solve, and reducing oil dependence has been an inevitable choice. For this, a huge number of engineers are constantly striving to find approaches to reduce fuel consumption, seek alternative fuels, and develop new vehicles that use little or no gasoline. Uh, People have realized that various types of electric vehicles and fuel cell vehicles are solutions for clean energy source. In fact, electrical cars are now known and fresh. It was popular during the 19th century, but it was very expensive as a kind of luxury of upper class. But the first production, the gasoline car, was mainstreaming because of its cost-effective price, and people start to ignore the development of electric cars. And today's electric cars integrate the latest achievements in scientific realms such as machinery, electronics, motors, intelligent control, chemical energy, computers, new materials, and engineering technology. And they are the result of a type of high-tech convergence. So there's no doubt that electric vehicles have broad prospects for development. And let's begin our concept development stage. It has three parts. The first is need analysis, and the second is concept exploration, and the third is concept definition. In the first phase, need analysis, as we all know, the main deficiencies of the current system, the fuel car, are the pollution and the depletion of resources. So R&D department need to control the cost on the electric car, including human resource and money. I don't think people may accept a related higher price than the original car, even if it is possible to save money and energy in the long run. Besides the price, users must pay attention to the life of this new system, which has many new subsystems and components. So the useful life of electric vehicles should be comparable to the level of the fuel car. And the next phase, function analysis. In this phase, the new system needs to translate operational objectives into functions and allocate functions to its subsystems. It has four fundamental functions. The first is charging system. It converts the AC power of the charging port to DC power. And the second is high voltage power distribution unit. It is a set of components that distribute the high voltage power to the drive motor controller, the electric air conditioner compressor, and the PTC heater, high voltage power equipment. And the third is power battery. It supplies power to the drive motor, and it is the power of the entire vehicle. And the last is drive system. It consists of three parts: drive motor, reducer, and the drive motor controller. The next phase, feasibility analysis. It is the tech realization for the former analysis. At first, we could encapsulate the charging system with DC to DC, which is a technical device that converts the DC power into DC power, mainly transforming voltage and current. And second, we could use the high voltage junction box. It could introduce the high voltage power from the charger into the power battery. So it could realize the function of charging in the power battery. And third, the power battery. It could be installed on the floor of the vehicle, and it could be cooled by natural air cooling. At last, we could use the drive motor controller to link the drive motor, the start switch, the meter, the gear switch, the throttle signal, the brake signal, and so on, so that the vehicle can be carried out in an orderly manner. And here is the last phase, needs validation. Based on some related studies, this project, the new system of the electric car is obviously reasonable because it meets people's needs for the use of cars and protection of the environment and resources in the future. Moreover, by comparing the research and development costs and the annual revenue, the risks and the costs are acceptable. Tesla is a good case in point. And here are the research costs and annual revenue of Tesla from 2010 to 2018. And it is clear to show that this system is making profit, which increases year by year. And here comes the second part of the concept development stage. It is called the concept exploration, and it will also use 4 system engineering methods to complete this part. And the first is operational requirements analysis. The second is performance requirement formulation. The third is implementation of concept exploration. And last is performance requirement validation. In the first phase, operational requirements analysis. Since in the new system, electric cars use electric energy to drive, so its biggest operational requirement is to solve its charging problem. If the user can't charge the cars in time and conveniently, the system can't be operated, and it will now attract more consumers and users' attention. And in the next phase, the performance requirement formulation. In order to translate this requirement into the whole system, electric car related companies need to popularize the charging paths as subsystems in every corner of every cities, every countries, so that when the users and customers electric vehicles need to be recharged, they can find the nearest charging paths to solve the urgent need. And in my opinion, it could be completed by 2 main parts. The first is the hardware, and the second is the software. The hardware is for the charging paths, and the software is for some mobile application on our cell phone to give some information for users. In the implementation of concept exploration, in this stage, the main 2 aspects needs to be considered. The technology company must first implement the function of the charging station and then let the user know and choose where to charge. An AC charging panel could provide AC voltage to electric. The corresponding company can develop a mobile app to provide users with the location and working status of the charging panel. For example, the charging panel must give the electric cars a good charging efficiency to save some times, and the mobile app will provide the user's information including the GPS and whether the charging panel is in good condition and so on. In the next phase, the performance requirement validation. Because this system is both need and technology driven. It needs customers and systems developers work to validate its performance. In detail, the company could arrange some customers to test these subsystems and the developers could operate and maintain, such like finding if there are some errors and bugs in the mobile applications and whether the charger pair could be regularly used in their life cycle. The third part of the concept development stage is the concept definition. It will explain what is an electric vehicle and what can electric car do. An electric vehicle is a brand new and alternative energy source automobile that uses electric motors and motor controllers for propulsion, instead of common propulsion ways such as the internal combustion engine. Electricity could be used as a fuel to power battery electric cars. It stores electricity in an energy storage device as a battery system. The electricity powers the wheels of cars by an electric motor. Electric vehicles have limited energy storage capacity, which should be replenished while charging into an electrical source. And the last part, I will list some challenges for the electric cars. And it has four basic challenges. The first is battery life. The second is charging efficiency. The third is electric vehicle charging source. And the last is raw materials for battery manufacturing. For the first challenge, battery life. Because electric vehicles are subject to power battery capacity, most electric vehicles could not reach long-distance driving conditions. Although there have been many electric cars that claim to have a large cruising range of more than 300 kilometers, the cruising range of electric vehicles is obviously dwarfed for pure electric vehicles that often travel between the two places. The reason for the short cruising range of electric vehicles is that there are technical problems in addition to the manufacturing costs of electric cars. With the advancement of science and technology, developers need to develop electric vehicles with battery life of 2 to 3 times the endurance. And for the second challenge, charging efficiency. Today's electric vehicles are not widely used because it consumes too much time to charge it. The original purchase of the car as a means of transportation is to improve our living efficiency, make it easier for us to go out. However, if an emergency situation which requires us immediately happens, such as going to the hospital, station, going to a meeting, the advantage of the fuel car will come out. Consumers expect that with the development of tech, the battery's power density will gradually increase. and the charging time will be short, and the endurance must be strong. And the next challenge, electric vehicle charging source. If the electricity comes from traditional sources such as coal, oil, or natural gas, then electric vehicles will not play a role in climate change. What makes people feel a bit strange is that the benefits of electric cars depend on their charging power because it all depends on the local energy production portfolio. A change in local energy production means that electric vehicles are sometimes more polluted than ordinary cars. If people live in places that rely on coal to generate electricity, the improvement of the environment for electric vehicles may not be much better than that of fuel vehicles. For example, in India, electric cars are almost the same as traditional cars, where power generation is still dominated by fossil fuels. And the last challenge, raw materials for battery manufacturing. Even if the global energy supply is converted to renewable energy, it will have to extract more cobalt, lithium, and other raw materials to make batteries. And it needs to be carried out in a sustainable and responsible manner. For example, more than 60% of the world's cobalt, the key source of lithium-ion batteries, comes from the Democratic Republic of the Congo. Researchers are working on new types of batteries that require less controversial raw materials, which will help the countries that have proposed a fuel vehicle ban to fulfill their promise of renewable energy in an ideal situation. At last, I really want to say thank you for listening and watching my midterm presentation. And that's the result of this day's I strike. And thank you, Professor.